Hi, my name is John Trumble. I'm with the Department of Entomology at the University of California at Riverside, and I was here to present Casey's Butler's talk on the effect of imidacloprid on plants and on the psyllids that feed on those plants. What Casey did was to use a novel technique called the electrical penetration graph, and this is where you hook an electrode up to the insect, an electrode into the plant, completes a circuit, and it goes to an oscillograph, and it produces a graph. And what that insect is doing varies with the graph that you see on the oscilloscope. So basically, what you have is a series of patterns on the oscilloscope that tells you what the insect feeding behavior is. And Casey went through and calculated all the different behaviors and determined that imidacloprid was stopping the insects from feeding in the phloem. And because the Libiribacter that's important here lives primarily in the phloem, the insect has to penetrate the phloem before the bacteria can be transmitted. And as a result, the imidacloprid was stopping the transmission of the pathogen. And it turned out to be a very successful approach, and we think that the electrical penetration graph can be used for many other insects and many other pesticides to find out precisely what the pesticide is doing to affect the insect's behavior.